Hello again everyone, welcome back to ptet.chemistry channel. So in this tutorial video, I'll continue these topical MCQs on topic 2, which is on atomic structure. So just like this first question is about electronic configurations. These are of an element. Okay, so you know you're given a list of first ionization energy, well, a list of not just the first ionization energy, but inside a data booklet you have like a list of elements, and then you have the first, second, third, I think the fourth as well, ionization energy. So you're just being asked which element has a second ionization energy higher than each of its neighbors in the periodic table. So these are of the element. So if we identify the element first of all, so this is group 2 is period 3, so that is just magnesium. This is period 3, group 13, that's aluminium, that is silicon, and this is phosphorus. So if we have a look in the one of the fastest thing you could do is just have a look in the data booklet, and you will see the third period continuously from magnesium, aluminium, silicon, phosphorus. So we're talking about the second ionization energy, right? So 1450, 1820, 1580, and 1900. So these are the value of the second ionization energy higher than each of its neighbor. So higher than each of its neighbor. So we also need to consider the neighbor as well. So if I just put in the sodium as well, and I put in chlorine as well. So sorry, sulfur is next to phosphorus. So the second ionization energy of sulfur is 2260, and sodium is second ionization energy is 4560. Okay, so each of its neighbors, so that means to the left and to the right. If you are here, you are magnesium. If you are here, you are aluminium, silicon, and also phosphorus. So this is just a list of value you can get from the data booklet. I'm just writing them down here so that you know they're straight from the data booklet, right? So if you are magnesium, you are here. This is not higher than any of its neighbor, so we can cross this out. If you are aluminium, this is a second ionization energy. Okay, and if you're aluminium, this is higher than magnesium, this is higher than silicon, so potentially we are looking at B. But let me just double check for the rest. If you are silicon, well, this and this are higher than the second ionization energy of silicon, so it's not silicon. How about if you are phosphorus? If you are phosphorus, this look pretty high, but then higher than each of its neighbor. So it's higher than this neighbor, but it's not higher than the neighbor that comes after phosphorus. So this is higher than this, so this is not higher than the neighbor. So this is also out. Okay, so read the second requirement very, very carefully. In this next question, so back in 1999, that seems like ages ago now. So researchers working in the USA believe they made a new element. So it had this particular electronic configuration. So they used Roman numeral back in a few years ago, until Cambridge decided to adopt the new system, which is just using the number. So there's group 14, group 16, and group 18. So this is a new system. If this question ever comes out again, then you will see the question coming out as these particular numbers, because even your periodic table in your data booklet, they show them as this numerical value rather than this Roman numeral. Okay, so looking at this configuration, you have fully filled 7s and 7p. You see 7s2, 7p6, we are therefore looking at the noble gas configuration. So we can be thinking about the noble gases, which are the group 18. All right. In this next question, so in this atomic structure, we also deal briefly about the idea of mass spectrometry. Okay. So in this mass spectrometry of Cl2+, chlorine can have chlorine 35, and chlorine 37. These are part of your case study. And your relative atomic mass as a result of this distribution of the isotopes give you 35.5, which I'm sure you know how to work it out. This question is asking you, however, how many peaks corresponding to Cl2 plus? It has to be a plus because in a mass spec, you have m over z or m over e. You've got to be a charged species. If your species in the mass spec is not charged, you do not see it at all because mass over 0 is nothing. Okay, it's infinity, so you don't see a peak at all. It's got to have a plus charge in order for you to detect it in the mass spec. All right. So what you could have is you could have a 35 chlorine and 35 chlorine because you have a molecule. So we're talking about combination. Yeah. So you can have 35 chlorine, 37 chlorine, and that can be combined with 35 chlorine, 37 chlorine, just like that. So your first chlorine could be that, your second chlorine could be that. In the end, you have 4 options, 35, 35. You have 35 Cl, 37 Cl, which actually incidentally give you the exact same mass as 37 Cl and 35 Cl. And the other one will be 37 Cl, 37 Cl. So that gives you 70. Well, I mean, the mass over the charge give you 70. The mass over the charge gives you 72. This is the one that I said they will overlap because they have the same mass. So altogether, how many peaks will you see? You thought that you only see 1, 2, 3, and you will be wrong because you have a molecule, and inside the mass spec, the molecule can be fragmented to give you further atomic ion. Well, I mean, to break up to give you the atom, which will be detected as the ion. So you could also get that, and the mass that you will get will be 37 and 35. So meaning to say, altogether you will see five lines. This as a result of the fragmentation of the chlorine-chlorine bond under the very high energy of a mass spectrometry. So a lot of students might have gotten 3, but you might have missed out on the atoms, okay, being detected as well in the mass spec of the molecule. Okay, so don't get confused. Okay, think about what does a mass spec do and why you will see the atom as well. In this next question, so we have gallium nitride. So not sure if you have heard about the new kind of battery charger. So gallium nitride makes charger for computers, for laptops, much smaller. In fact, they are much more high density battery these days based on gallium nitride technology. So gallium nitride is an ionic compound containing Ga3 plus ion. Now you want electron arrangement of nitrogen ion. If you have Ga3 plus and you have GAN which has no charge, therefore your nitrogen must be 3 minus for the 3 plus to balance out the 3 minus. And if you look at 3 minus configuration, that has a neon electronic configuration in a square bracket. Alright, and the neon configuration has 10 electrons total. So there will be a period 2, completely fill the 2s and the 2p. 2 plus 2 plus 6 will give you 10 electrons altogether. That is the configuration for neon. That's the configuration for the nitrogen 3 minus present in gallium nitride. In this next question, 25, we're talking about the radius of the second atom greater than the first atom. So we're talking about atomic radius. Atomic radius from your sodium to chlorine decreases that way. So this is across a period, or you can think about the number of proton or proton number or atomic number. So this is atomic radius. So we will have magnesium somewhere there. So magnesium is smaller than sodium. So the second atom is greater than first atom. It's not what you want. So we can cross out A because magnesium is smaller than sodium. You want the second one to be bigger than the first one, alright? So that is across a period. Strontium and calcium, that is group 2. When you have group 2, we're going down a group. down a group, you have more shell. So more shells that are filled, more filled electronic shell. Therefore, radius definitely increases, all right? Your atomic radius definitely increase. In your group 2, calcium is above strontium. So calcium, so basically I'm talking about beryllium, magnesium, calcium, strontium. So strontium has additional electronic shell than calcium. Strontium will be bigger than calcium. So again, strontium is bigger than calcium, so that's not what you want. Phosphorus and nitrogen. So group 15, you will have nitrogen and phosphorus. So nitrogen has lesser filled electronic shell than phosphorus. Phosphorus is again bigger than nitrogen, so that's not what you want. Going to the next one, chlorine and bromine. So chlorine, bromine, iodine. This is down group 17. So bromine has one more filled electronic shell than chlorine. Bromine is bigger than chlorine. So you got your answer D there. So a bit confusing, I guess, but then, it's just reading the question, thinking about across a period and also down a group. Okay, so this is the end of this 5-question series on atomic structure topical MCQs. If that was helpful, make sure you subscribe to the channel, click that button on the bottom right, share the channel widely with friends, your class group chat, your teachers, and your social network of contacts. So thank you for watching. I'll catch you in the next video.